Good evening, everyone. Really pleased that so many of you have chosen to join us this evening and spend your evening hearing about sewage. My name is Ali Morse, and I am the Water Policy Manager at the Wildlife Trusts. I work across all areas of water policy, from the water industry to flooding to aquatic species. But I don't do a lot in my day job on private sewerage, so I'm more here this evening in a personal capacity. As Sophie said, I was previously at Hampshire and Isle of Wight Wildlife Trust, where I helped to set up the Watercress and Winterbournes project. And I'm also local to the area, so I live not far from the bottom of the River Itchen, and it's a fantastic part of the world to live in with all the chalk streams. My interest really here tonight is to talk about the impacts of sewerage on our chalk rivers and to try and unpick some of the detail behind that. The other thing I should probably say by way of introduction is that, as I said, I don't do a lot on sewage in my day job. I don't consider myself an expert, but these are things that I've picked up throughout my work and wider interests. So I hope that they will be of interest to you. So I thought we would start by looking at sewage treatment in general. A lot of the sewage throughout this country is dealt with by public sewage systems operated by the water industry. And in these systems, urban wastewater, meaning the wastewater from our homes and from our businesses, is collected, treated, and the final effluent discharged back into the environment. And this is a huge operation. So across England and Wales, we have over 500,000 kilometres of sewers that collect our urban wastewater. These systems serve nearly 26 million properties across the country, and we have over 6,000 sewage treatment works or wastewater treatment works or wastewater recycling plants, however you like to refer to them. So a huge operation to manage and process our wastewater. In terms of what this looks like, there are a couple of key stages that our sewage treatment process goes through. So once the water has been collected from our homes and businesses and it ends up at our wastewater treatment works, the first process is screening, where large items that really shouldn't be in the wastewater are screened out so that the rest of the treatment process can be more efficient. And this includes big things that you might expect to find in our wastewater, although they shouldn't really be there, like nappies and wet wipes, and even sometimes quite obscure things like bricks. Now, the kinds of things we get in our wastewater system are the things that people might flush down their toilets, but there are also things that can find their way into the sewage system through things like street drains. So there can be a lot of large contaminants in our wastewater, and so the first step is to screen those out. Once that has happened, then the primary treatment, the first stage proper in the treatment process, takes place. And this employs big settlement tanks where the solid parts of our wastewater sink out into the bottom of the treatment tanks, and they're termed sludge. And the liquids, the bit that's left over, are sent on to the next stage for further treatment. In this next stage, this secondary treatment, the tanks are aerated, and this puts oxygen into the wastewater to help what we'll call the good bacteria to break down other harmful pathogens in the wastewater. And these primary and secondary treatments are common across all of our sewage treatment works. In some sewage treatment works, but not all, we then have a tertiary level of treatment. So this is a third step in the process. And this is the additional level of treatment that will do things like remove phosphate from our wastewater. It could remove endocrine disrupting chemicals. These are chemicals that, if they're discharged into the water environment, they can really affect the growth and development and the reproductive success of aquatic animals like fish. So really important that they are screened out. And these kinds of tertiary treatments can use UV treatments, they can be chemical dosing. And there are different tertiary treatments employed in different places depending on what the local issues are, such as how sensitive the receiving waters would be. And then finally, there's usually a filtration sort of final stage before the water is then returned to the environment. Meanwhile, the sludge that settled out in that first primary treatment is taken off for disposal, and this can be used because it's very rich in nutrients like phosphate. It can be spread to agricultural land as fertilizer, or it can be used to generate power, so such as through anaerobic digestion, where the sludge is broken down under low oxygen conditions, and this creates a biogas. So the waste product from the sewage treatment process can be quite useful if it's managed properly. But going back to the water, once we've been through that primary, secondary, and sometimes that tertiary treatment process, what we end up with at the end is treated wastewater, so cleanish effluent that is then returned to the environment. The reason I've talked through this process is because private sewerage, the domestic level wastewater treatment plants, basically do the same sort of functions, but on a much, much smaller scale. Now, this is what takes place when our wastewater treatment process is operating more or less as it should be. What we also need to think about in terms of the environmental impact of sewage is what is happening when it's not operating properly. And I'm sure you will have heard over the past couple of months a lot of media coverage of storm overflows. We have these overflows on our sewerage systems to provide a bit of a safety valve. And the reason they're necessary is that in large parts of the country, our sewage systems not only take the domestic water from our sinks, our toilets, our baths, our showers, they also take water from the outside environment, so street drainage or rainwater which falls on our roofs and is discharged into the sewer system through our downpipes. And under dry conditions, we're not really getting any of that additional rainwater into the sewerage system. As you can see in the diagram on the left, our wastewater flows through the system to the wastewater treatment works, and the final effluent is discharged into our rivers or into the ground. When we get a bit of rainfall, there's more volume in that sewer system. And so you can see that there's more water than can pass through the sewage treatment plants fast enough. It's sort of up to capacity. And so some of that excess water is drained off into a storm tank. And this is effectively a holding area that holds this excess water until there's capacity in the wastewater treatment works again. And then it will be pumped back through the works and discharged and treated as normal. But the main problem occurs when we have very heavy rainfall, and that's really what these storm overflows are supposed to deal with. We'll have huge volumes of water coming in from particularly our urban landscapes where we have a lot of hard paved areas, so that water can't infiltrate into the ground. So all of the water from streets, from car parks, and from the roofs of our homes and buildings runs into the sewer system. Huge volumes that can't be accommodated in the system. And so these storm overflows allow that excess wastewater to be discharged straight into the environment with minimal treatment. This is really only supposed to happen under extreme circumstances. But what we've seen in the news over the past couple of months is that these storm overflows are operating more and more frequently, far frequently than the system intended them to and the legislation was designed to allow. And there are a number of reasons for this. Due to climate change, we're having more extreme rainfall, so the systems are becoming overwhelmed more frequently. There can also be problems with blockages in the sewer system, so the water can't get through fast enough and backs up and overflows via these outlets into our rivers and seas. And there can be issues with a lack of maintenance to the system, so problems in the system that then cause that water to overflow into the environment. So when we're thinking about the impacts of sewage, it's useful to think not just about the impacts that wastewater might have when everything's going as it should be in those normal wastewater treatment processing operations, but also what's happening when we are seeing the sewage system overwhelmed by this heavy rainfall. The impacts of sewage contribute to our rivers being in a particularly poor state. Last year, the Rivers Trust published the State of Our Rivers report, which looked at the overall state of rivers across England. And as you can see on the map, the key on the bottom right shows everything in a sort of reddish peachy or pinky colour, is not currently hitting targets. And as you can see, the vast majority of the rivers across England are in those kinds of colours. So this is showing the ecological status of our watercourses. And the donut that you can see on the left, you can see only 14% of our rivers are in good ecological health at the moment. That's one half of the way that we consider the health of the water environment, and the other half of the way is the chemical status, so the pollutants that are in our water environment. If you look at the middle donut, that picture is even worse. Every single watercourse across England is polluted to the extent that it's not achieving its chemical targets. So this means no rivers are in good chemical health. And because we assess the state of our rivers by considering both of these components, the ecological and the chemical, we then make an overall assessment based on those two components. And because everything is failing for chemical, then that means that nothing is healthy overall. So not a single river in England is considered to be meeting its targets at the moment. There are a huge number of reasons that contribute to these failures. And we assess the health of our rivers by looking at a huge number of components under the ecological side and under the chemical side. But one that I wanted to focus on is our phosphate failures. Now, phosphate is something that finds its way into our water environment from a range of sources, but sewerage is one of the main components of that. And as you can see from these charts, a large number of watercourses across the country fail their standards due to phosphate pollution. So for our rivers, 55% were failing phosphate standards, and for our lakes, 73% at the last time that the assessment data was published by the Environment Agency. So this is something that's monitored and updated periodically. 2019 was the last full set of data that was published, and it shows that phosphate is a real problem across many of our watercourses. If I showed you a similar graph from the previous batch of data from 2016, it would look almost entirely the same. And so phosphate is something we really haven't managed to tackle in terms of pollution to our water bodies. Why is this a problem? Well, phosphate is a plant nutrient, and at natural levels, it feeds the aquatic plants that are found growing in our rivers, and a certain amount of this nutrient is necessary for healthy growth, and it supports plants like ranunculus, the water crowfoot, which provides a food source and an important physical habitat for the aquatic insects that are found in our rivers, and including our chalk streams like the Test and the Itchen. But when these phosphates are present at excessive levels, it can cause changes in the aquatic plant community. Nutrient-hungry algae, both free-floating in the water and filamentous, so growing over and smothering other plants in the channel, they start to outcompete the plants that are usually present in rivers. And the algae smother the aquatic plants. They block out the light and they can cause them to die. And when the nutrients in the watercourse are used up, the algae then die back too. And the bacteria that breaks down all of this dead plant material, this organic matter, use up oxygen in the water, so they cause oxygen levels to drop. The material itself is deposited on the riverbed as fine sediment. And this is a particular problem on gravel-bottomed channels, as it chokes the aquatic insects, the aquatic invertebrates that live amongst the stones, and it suffocates the eggs of fish like salmon, which are laid in gravelly depressions in the riverbed. And in extreme cases, the low oxygen levels can cause substantial fish kills. So phosphate pollution can affect the entire aquatic community of our river system. And it can also prevent us from using and enjoying our rivers, our lakes, our coastal waters, because algal blooms and their impacts threaten things like angling, shell fisheries, and they contribute to flood risk. So phosphate is a big problem across our watercourses. Where does this phosphate come from? Well, it comes from a number of sources, which can make it quite tricky to tackle. And that's one of the reasons that we haven't made substantial progress in bringing those phosphate pollution figures down. But understanding where these different inputs can come from can help us to understand and control levels in our waters. Phosphate occurs naturally and it is found in sedimentary rocks, those formed in lakes and seas by deposited sediments. And it gets into those rocks because it's present in the bodies of animals, particularly in things like bones and teeth. And so it was incorporated into these rocks during their formation when dead creatures were deposited on the bottom of our lakes and shallow seas. From these rocks, it then slowly leaches out into groundwater. And we have naturally occurring levels of phosphate that feed the plants found growing in our rivers. But in some locations in the world, these rocks have a much higher phosphate concentration in places like Spain and Morocco. And in these locations, phosphate is mined because it's really useful to society. So it's used in fertilizers and in animal feed. And that means that from farmland, it finds its way into our rivers in nutrient-rich runoff from the soils and also in animal waste. Also, when we eat crops and animals, as well as processed foods which have phosphate added to them, the chemical travels via us through the sewage system that deals with our waste. And if it's not removed by the treatment, it then flows out into our rivers. Phosphate is also an ingredient in cleaning products like dishwasher detergent. So where these are used in our homes, they too contribute to the loading in our wastewater. And finally, leachate from waste, which is rich in phosphate, can also pollute our waterways. So there are a whole host of ways in which this phosphate pollution can find its way into our river systems. Last year, Water UK published their 21st Century Rivers document. Water UK are the industry body for water companies. And they took a look at the data concerning the impacts on our rivers, which is published by the Environment Agency. Now, I should say there are numerous different ways that you can sort of interrogate and display this data. This is the way that Water UK chose to share it. And what they're showing in this diagram is the sectors responsible for the reasons that England's rivers are failing their ecological standards. So the middle part of the chart shows the sectors, and then the outer part shows the specific failures that they are contributing to. You'll see that overall, the sector responsible for the greatest number of failures in our river systems is agriculture and rural land management. A number of the things that the farming sector can contribute in terms of pressures on our river systems do contribute to phosphate and also another fertilizer, nitrate, into our river system. So if you see on the outside segment, nutrient management and soil management are quite significant. And these are where fertilizers, either chemical fertilizers or manure, are applied to farmland. And if they're applied in excess, can run off into our river systems. Livestock can also contribute directly through their waste. So we can have lots of nutrient sources impacting our river systems due to agriculture and rural land management. However, if you then move on to the second main segment on the inner circle, you see that the sector who is next in line in terms of the most impacts that it's responsible for is the water industry. And on the outside of that chart, you can see that wastewater treatment is a huge chunk. And in fact, it's bigger than any one of the individual agricultural impacts. So the single biggest pressure is wastewater treatment. Now, this is referring to the water that is coming out at the end of that wastewater treatment process from those sewage treatment plants. So really interesting to think about the fact that this is water that has been through a treatment process, it's being discharged back to the environment, but it's still responsible for this large number of water failures. And often that is because of the nutrient content, the phosphate content or the nitrate content that's in that wastewater. The next segment on the chart is overflows. So those are the storm overflows that I was talking about earlier, when we have that heavy rainfall or those blockages or that lack of maintenance that causes untreated wastewater to overflow into the environment. And it's interesting there to compare the two. So even though storm overflows are putting untreated sewage into the environment, collectively they're not having as big an impact as the treated wastewater. Now, I said that we can also think about private sewerage as a sort of miniature version of these wastewater treatment plants. And what we can see on the last segment here is that in terms of the urban development and transport sector, wastewater there is shown as a very small component. And so this is the impact that private sewage systems are having on our rivers. So what do we mean by private sewerage? Well, anyone who doesn't have their wastewater taken away through the sewage system and dealt with by the water companies has some form of private sewerage system. Historically, a lot of these would have been what we call cesspools or cesspits, and these are effectively just a big tank in the ground that all your wastewater goes into and then has to be taken away and disposed of by a company who come and empty your tank for you. But those are not very common anymore. And the majority of private sewage that we see today are either septic tanks or small package treatment plants or small sewage treatment plants. The difference between these is that septic tanks are chambers that are placed underground and which your wastewater from your home discharges into. And there are bacteria in these tanks which help to break down the waste. Very similar to the water industry process, the solids sink to the bottom, forming a sludge, and the liquid then flows out into a drainage field. And here, more bacteria in the ground will help to treat it and help to break down those components of the wastewater as it soaks away into the ground. Because these systems don't have any form of active treatment, the end product, that effluent that comes out of the system, isn't as clean as it could be. And so these systems are not allowed to discharge directly into watercourses. More modern private sewage is sewage treatment plants or small package treatment plants, as they're called. And these work in a very similar way, but in addition, they use powered mechanical parts to aerate the bacteria. So again, very similar to what we saw in the water industry sewage treatment works, where the treatment tanks are aerated to help more efficient treatment of the bacteria in the waste. So this makes the package treatment plants more effective at treating the wastewater. What comes out of them is cleaner than what would come out of a septic tank, and this means they are allowed to discharge directly into flowing water, although many of them will also discharge into a soakaway first. A few years ago, Hampshire and Isle of Wight Wildlife Trust and its partners in the Test and Itchen Catchment Partnership undertook a bit of a mapping exercise to try and understand where private sewerage existed across the Test and Itchen catchment. This wasn't, unfortunately, a straightforward exercise because there is no national map of where private sewerage exists, but we were able to work it out. And the way that we did this was we obtained digital mapping layer from the local water company, Southern Water, showing where their sewage systems are, so where they have sewer provision across the area. And then we obtained a data layer that's open source data, freely available on the internet, that showed where all the properties are across the country. And if you take one away from the other, what you're left with is properties which are not served by main sewerage. And so the assumption is that all of these properties have some form of private sewerage instead. The vast majority of the population tends to be concentrated in urban areas, and usually these will have pretty good public sewage provision. So it probably comes as a surprise to a lot of people who live in Southampton, like myself, or Eastleigh or Winchester, to see that there's actually quite an extent of private sewage across the country. So all of the little orange dots that you can see on this map represent a building that is not served by Southern Water's sewage systems. If I zoom in on the detail a little more, you can see that in some of the areas surrounding our watercourses, the Test and the Itchen, We have a lot of properties that have this private sewerage, and so there is a concern that the effluent that's coming out of these private sewage systems could be having an impact on the ecology of our chalk streams. Natural England, the government's conservation advisors, undertook a bit of research because of this concern. They looked at the impacts that private sewerage could potentially be having on designated sites. So if you think back to the donut diagram from Water UK, we saw that the segment that private sewerage was responsible for was really quite small. So we know that they're not having a massive impact upon our watercourses at that national level. But we don't know if they're having an impact more locally, and particularly if they're having an impact on sites which are designated for their nature conservation interest. Often these might have much more stringent water quality requirements because of the important species that are found there. There is a risk that private sewage could be having an impact on the ecology of chalk streams like the Test and the Itchen. So Natural England looked at the impact of phosphorus inputs from small sewage discharges on designated freshwater sites. And they did this by firstly undertaking a literature review. They looked at what had been published already. And they also commissioned 2 case studies looking at particular designated sites that had a high level of private sewerage in their catchments. From this piece of work, they identified a number of key factors that affected the risk of phosphate pollution posed by septic tanks. And this included the things you can see in the table at the bottom, like the age of the tank, what kind of condition it was in, how well it was maintained, how frequently it was emptied or desludged, whether it was the right size of tank for the household that it was serving, and how close it was to the watercourse that it could be affecting. Overall, their literature review and case studies found that a large number of septic tanks don't currently function properly. It could be that they're incorrectly sited or that they're not properly maintained. And the data from these published studies and from their own case studies showed cases where septic tanks have a significant impact on the downstream phosphate concentration in the river compared to the upstream levels, which are not impacted by septic tanks. Downstream water quality saw up to a 700% increase in phosphate levels. It's really significant. This suggested that these small sewage discharges, either septic tanks or package treatment plants, could give rise to considerable ecological damage at that very local scale. At the catchment scale, that impact can be reduced because overall in a large catchment, you may not have large numbers of private sewages discharging into the watercourses, and you're often considering the water quality at quite a large scale across a whole water body. But where you're thinking about the impact on a designated site, where you're looking at that more local level, it did indeed look as though there was a risk that private sewerage could be impacting the nature conservation interest of those designated sites. So the next step that Natural England took was to develop a risk assessment tool in order to assess the significance of septic tanks around freshwater sites of special scientific interest, so those sites like the Itchen, which are designated for their nature conservation interest. And they undertook a screening exercise looking at 20 of those sites. And one of those was the River Itchen. And you can see the risk map here that was generated by that exercise. So they identified that particularly discharges that were in close proximity to the watercourse or in sort of geological features that would sort of feed quite quickly into them were of particularly high risk. So because of these concerns, because of the known impacts of private sewage on our watercourses at that larger national level, and also the concerns about those more local impacts on designated sites, the government decided to take action in trying to tackle the pollution that can come from these private sewage systems. And they introduced what are known as general binding rules. What these are basically a set of rules that you as a septic tank owner and operator need to comply with. And if you can't comply with those rules, you'll need to take action. These are not the rules in full detail. It's quite a lengthy piece of guidance to sort of read through and understand. So I just thought I'd pick out a few of the headlines here and then go to talk about them in a little more detail. But what the rules meant overall was that if you had an existing discharge, so that's a septic tank or package treatment plant that was in place before 2015, you had to meet a certain number of requirements. And these included that you can only be discharging a relatively small volume of water, so 5 cubic meters if you're discharging to a watercourse, or 2 or 3 cubic meters if you're discharging directly into the ground. They can only serve domestic properties, so not businesses. They must not cause pollution, and I'll come back to that in a little while. And where the septic tanks are discharging to water, so if you remember the diagrams at the beginning, septic tanks don't treat the waste to as high a standard, and so they're not allowed to discharge directly to watercourses. If you do have one, you would instead need to consider whether you could connect to a foul sewer, whether you could replace your septic tank with a small sewage treatment plant, one of those package treatment plants that does treat them to a higher standard, or whether you could add a drainage field so that rather than going into the watercourse directly, your effluent is then soaking away into the ground. And it also brought in a requirement that if you did have one of these septic tanks discharging to a watercourse, which isn't allowed, you would need to undertake these upgrade works if you were going to sell your house. The rules also set out that the tank system that you have should meet the British standard that was in force at the time. It should be the right capacity for your household, and that you should undertake regular maintenance and emptying. And the final requirement was to tell the new prospective owners when you're selling your house that there is a private sewerage system there. Any new discharges, so any septic tanks or package treatment plants that were put in place after 2015, there were some additional considerations as well. So firstly, you'd have to consider connecting to a foul sewer instead of putting in a private sewerage system. And generally, if you're within 30 meters of the sewer, that would be something that you'd be required to do. Only if you're further away than that, and so it's a much bigger effort to connect to the sewer system, would a private sewerage system be considered. There were also restrictions on how close you could be to certain designated nature conservation sites, and in particular to chalk streams as well. So within a certain boundary, these private sewage systems would not be allowed. And a requirement that the stream that a package treatment plant was discharging into should have year-round flow, so you wouldn't be allowed to discharge into something like a Winterbourne, which only flows during part of the year. One of the questions that is often asked is, well, if I do have one of these systems which isn't compliant, when do I need to upgrade? And I've seen websites that suggest particular dates by which an upgrade should be undertaken, otherwise you would be breaking the law. From looking at the general binding rules, I can't see any specific dates set out in those myself, even though there are lots of articles out there saying by 2020 or by 2022 or various other dates. On the government website, which hosts the general binding rules, if you scroll down to the very bottom of the page, you can see a section saying updates, and this can give you information about what updates have been made to this web page over time. And so I had a quick look at this, and it shows firstly that in 2018, the web page was edited to say that where properties with septic tanks that discharge directly to surface water, so those which are not allowed, are sold before 2020, responsibility for the replacement or upgrade should be addressed between the buyer and the seller. Now, this to me suggests that after 2020, that would be something that would automatically have happened. So those systems would have already been required to have been upgraded. And so there would be no need for that conversation between parties when selling a house. But later on, the site appears to say your discharge must not cause pollution. If you have a septic tank that discharges directly to a watercourse, you need to take action as soon as possible. So it seems that that 2020 date that has previously been talked about on external web pages and articles isn't explicitly set out within the general binding rules. There is a sort of indication within the rules that as soon as you become aware of the problem, you should be taking action to upgrade it as soon as possible. And it talks about ideally within 12 months. However, currently passing through Parliament is the Levelling Up and Regeneration Bill. And although it doesn't contain one yet, we understand that there is an amendment likely to be made to that bill, which will add in the requirement for the establishment of a register showing where all septic tanks and other private sewage systems occur. So it could be that with the establishment of that register, that will create a greater onus on making sure that all tanks are legally compliant. So that might be something that's coming down the line. Most people don't tend to spend a lot of time trawling government websites just to find out whether there might be some new form of legislation that might apply to them. So when these general binding rules came out, there was a lot of information put together to help try and communicate these messages out to the owners and operators of private sewage systems. And although, as you saw in the previous slide, there have been changes made to these rules and updates over time, a lot of this information is still really useful to get a general sense of what the sort of requirements might be when managing your private sewage system. One of the most important things to do, particularly if you're new to a private sewage system, if you've just bought a property that has one, is to find out a little bit more about your system. Find out where it is. You'll usually see a lid somewhere in your garden or your grounds that will show you where your tank is located. Find out whether it's shared. Some properties have individual private sewage systems, but other developments have a shared package treatment plant that a number of properties feed into. So if you think that might apply to you, talk to your neighbours, find out how it works. And find out where it discharges to. So locate your soak away. This will normally be visible as a gravelly or grassed area. And it's important to know where this is because it plays an important role in helping to clean up the effluent from your tank. Next, check your system. So if it's working properly, your soakaway shouldn't be waterlogged. There shouldn't be pools of water running off into nearby ditches or watercourses. And if you look inside your tank, the effluent, the water component of the waste should be relatively pale or even clear, and it shouldn't really be too smelly. So if you are having any of these signs, it's an indication that something isn't working well within your tank. Next is finding out whether your tank is compliant with these general binding rules. So looking at how much water your tank is discharging, the 2,000 litres or 2 cubic metres, if you're discharging into the ground, or 5 into a watercourse. The reason these are called general binding rules is that they are a sort of standard set of rules that everyone can comply with. And if you are satisfied that you can comply with these rules, then you don't really need to do anything else. However, if you can't comply with any of those rules, you either need to think about rectifying that, making some kind of changes to your system, or applying for a permit. So systems that aren't compliant with these rules and can't be compliant with these rules will need to make sure that they have a permit in place. The permitting system and the general binding rules are designed to protect the environment from the impacts of this sewage. So it's likely that there will be some kind of conditions placed upon any permit that you might get to make sure that your system isn't polluting the water environment. The general aim of the rules is around preventing pollution, and the general binding webpage sets out details on how you can do for this, some of the signs you should be looking for. So sewage smells, whether your system is overflowing, particularly with sludge, whether you're seeing things like white scum or foam on the water, which is an indication that the effluent that's coming out isn't as clean as it should be. Next on the list of top tips is to fix any faults with your system. And it's worth me saying that anything that I'm showing here on a green outline are the things that are part of the general binding rules. So these are your legal requirements. The things on a blue background are best practice tips, which will help you to keep your system in good condition. So it is a requirement to fix any faults with your tank, and things like gurgling pipes, your pipes making a noise, perhaps because they're partially blocked, discoloured effluent, odours coming from your tank, as I mentioned earlier, a swampy soakaway, or even just lush grass, which is showing you that there's a lot of water and nutrients going through the area. And sewage fungus, which is something that will grow in waterways if there is sewage pollution. It looks very much just like grey cotton wool in the watercourse. So these are all signs that there's a problem with your system. One of the most common problems is that tanks are not functioning well because they're too full and they need to be emptied. Another big problem is that the pipes feeding your tank might be blocked, and you can clear these with boiling water or drain rods. But if you've got any more substantial problems, it's important to get them fixed as soon as you can. This helps prevent ongoing pollution. If you've got sewage coming out of your tank, that can be a health risk. And the longer you leave it, there could be escalating repair bills. The general binding rules recommend that you use an accredited engineer, and British Water have a list of these accredited service engineers on their website. Next, in terms of requirements, is to empty your tank. So again, this is one of those legal requirements. Private sewage systems need to be emptied of sludge, and the frequency will depend on how big your family is, how much water you're putting through your system, as well as how well you've maintained it. But the general guide seems to be that roughly annually should be about right for an average family. It's important to make sure that the company emptying your tank is a registered waste carrier, because if they're not, you're ultimately responsible for whatever they do with your waste. So if they don't dispose of it properly and it causes pollution, that could ultimately come back to you as a householder. To make sure that they are, you can ask to see their certificate, or you can look up a list of registered waste carriers on government websites. It's also important to think about what else you're putting into your septic tank or package treatment plant. Obviously, the water and your toilet waste will be going into your tank, but also any cleaning products that you're using in your home, in your sinks, your toilets, your baths, will ultimately be going into your tank as well. If products aren't explicitly designed for these systems, they can be quite damaging to the bacteria. So you will see on cleaning products somewhere on the label, it might say suitable for septic tanks. And these are products which are specifically designed to not harm the healthy bacteria in your tank, which are important for keeping your tank environment healthy. It's important to remember that those bacteria help to break down and treat the waste material. So anything you're doing that's upsetting those bacteria could cause you problems with pollution. If you can't find a version that specifically says suitable for septic tanks, it's worth going for something that just says environmentally friendly, because often they will also not have those harsh chemicals in them. So try and avoid things like bleaches, disinfectants, antibacterials. And also don't use these products in large quantities, because even if they're not too harmful, if you use a lot of them in your system, again, it can upset the bacteria. Just like the water industry treatment process, they have the primary and secondary treatment processes. You might remember they have that tertiary treatment in some locations, which can do things like remove phosphates. Well, private sewage systems don't have that ability. So some of the phosphate will settle out in the sludge, but everything else remains in the effluent and is discharged out into the environment. It used to be suggested that using phosphate-free products would help you to protect your local rivers and streams. Now, this is one of the areas where things have actually moved on a little. A couple of years ago, the Upper Itchen Initiative, a stakeholder group of organisations and individuals concerned about the impacts on the Itchen system, looked at the phosphate content in domestic cleaning products, because they recognised that all of the private sewage in that area would be discharging into the Itchen watercourses, and there were concerns about the impact that could be having on the ecology of the headwaters of the Itchen. So they commissioned a piece of research that looked at the kinds of cleaning products that people might be using in their homes, and which would ultimately be finding their way into the water environment. Now, as you can see here, one of the worst offenders for phosphate content was dishwasher products. Almost 40% of those that were looked at during the study were determined to have a high phosphate content. We fall under the EU detergent regulations that came into force in 2005. And one of the things that these regulations required was that the labelling set out on detergents the ingredients that they contained. This had to show the percentage of a particular ingredient in these detergents, whether it was less than 5%, 5 to 15, 15 to 30, or over 30. And as you can see from the photo on the right-hand side, a number of dishwasher detergents were identified as having over 30% phosphates by their labelling. Now, remember that that's the biggest category that was required to be shown. So when something says over 30%, we don't know if it's 32% or 40% or 80%. So quite significant amounts of phosphate in these dishwasher detergents. Under the regulations, the EU also allowed countries to set limits on the phosphates that were in things like dishwasher detergents and laundry detergents. And in the UK, we had actually plans to bring in our own limit. And then in 2012, the EU regulations were updated, and they brought in a requirement that there would be a maximum limit of 0.3 grams per standard dose of dishwasher detergent by 2017. I didn't know what that meant really in terms of a percentage, so I weighed a dishwasher tablet last night to find out. And my dishwasher tablet weighs 16 grams, which means that it would be allowed less than 2% phosphate. So you can imagine the decrease in phosphate in dishwasher detergents that regulation would bring in. Products would have to go from upwards of 30%, we don't know what kind of percentage, down to less than 2%. We, as I said, were due to bring in that requirement in 2017. As far as I understand it, the implementation was delayed slightly due to lobbying by the detergent making industry, but that limit should have applied from 2019. So it should mean that any dishwasher detergents that you now find on the shelves in your supermarket should have nowhere near the phosphate content that they previously did. However, the phosphates were there for a reason, and something has to replace the function that those phosphates were delivering. They were there as a surfactant, and they're going to be replaced by a different chemical in the dishwasher detergents. Now, we know that some of those phosphates have been replaced by a chemical called phosphonates, which are quite closely related to phosphates. And there are also concerns about the environmental impacts that they could have. They're understood to be not quite as damaging, but potentially still not ideal to be discharging into your water environment. So if that's something that you're concerned about, then even though the phosphate content is now lower than it used to be, it's probably still worth considering eco detergents instead, because non-eco dishwasher tablets could still contain things like chlorine bleaches. They can contain plastics, especially the pods. They can contain a range of other toxic chemicals. And so choosing an eco brand will mean that you're not having to worry about any of those potential contaminants, not just the phosphate content. Ethical Consumer magazine published a review of dishwasher detergents, so it's worth Googling that and having a look at their recommendations if you're interested in using something in your home that won't have any of these problems associated with it. On now to the last few tips for our private sewerage systems. Household waste that you put down your sinks or toilets can quite easily block and damage your private sewerage systems. So you should look to bin instead of flush things like kitchen towels, tissues, cotton buds, and certainly the bigger things like nappies and sanitary items. These can all quite easily block your tanks and pipes. The other thing to avoid is flushable wipes. A lot of wet wipes are labelled as flushable, but this just means that they will physically flush away. They won't block your toilet pan. Doesn't mean that they will break down in the wastewater treatment process like toilet paper would. So these wet wipes can really clog up our private sewage systems and our public sewage systems as well. Another thing to be wary of is fats, oils, and grease, known as fogs. And the picture on the left from Thames Water shows a sewage pipe. So this is a sort of 10 centimetre diameter wastewater pipe. This is in a leaflet aimed at the restaurant trade because they are big generators of fats, oils, and grease. And so it's very common that pipes associated with food retailers can be blocked by these components. They are liquid when you sort of flush them away down your sink, but they can solidify and congeal in the sewer pipes and form these really quite substantial blockages. Food waste can also fill up your tank much quicker than it otherwise would. The more you have going into your private sewerage, the faster you might have to empty it. So worth bearing in mind the cost benefits there as well. Finally, things like paints, solvents, and chemicals can also upset your tank bacteria, and so take them to a civic recycling site. And medicines, excess medicines should be returned to pharmacies. Again, putting down your sewage system can kill your necessary bacteria, so not something we want to do. Just like we saw with the storm overflows, if you put large volumes of water into your private sewage system, it can become overwhelmed, and this can cause untreated sewage to flush out of it. So one of the best things you can do is make sure that your non-wastewater, your rainwater, is not connected to your system, and instead it's going into a soakaway. So your roof gutters and your downpipes should not feed into your sewage system, but go off into a soakaway elsewhere on the property. Even if that's something that you realise is a problem and you can't rectify immediately, something you could do as a bit of a short-term fix is add a water butt. So that would have the benefit of keeping a good proportion of your rainwater out of your water system. And as well as the obvious garden uses that most people will be familiar with, good to remember that water butt water is great for washing your car because it doesn't have the calcium that our tap water has, so you won't get those white streaks on your car. Great for watering your house plants as well because it doesn't have the chemicals that our drinking water has. Also, try and avoid putting too much water from within your house into your system at the same time. So don't have a bath, run the dishwasher and run the washing machine all at the same time. Try and stagger them different times during the day and overnight so that you're not putting too much into your system in one go. Another good tip is to keep a record of what's happening with your system. So keep a note of any maintenance, how frequently you've had it emptied, any servicing you've had undertaken. This is quite useful for if you encounter any problems because you've got a bit of a record of what's happened before, so that might help contractors to identify and fix the problems that do arise, and also really useful if and when you come to sell your home because that's something that a new purchaser would be interested in. Now, I'm not saying you need to record every single day how your septic tank is feeling, but it can be useful to keep something like a tank diary, which just keeps all of this core information together so that you've got that record if needed. And finally, on the list of 10 tips, it's important to remember that legal requirement to inform a buyer in writing that your property has a septic tank or small sewage treatment plant if you're selling it. Although the requirement is just to inform them, if you can also provide wider information about the system, then that will help to reassure them, particularly someone who hasn't lived with a private sewage system before, might potentially be quite nervous about what they're taking on. How expensive is it going to be to maintain? Am I going to have any big problems with it? And so if you can give them that information about how you've had it maintained and how they should operate it, that will help to reassure them that they're not taking on something which could be a liability. So that brings us to the end of our top tips on private sewerage. To recap, I think that the main points that people with systems, particularly if they're new to them, should be thinking about are familiarising yourself with the general binding rules. And if you can't comply with those, think about how you could improve your system or recognise that you will need to apply for a permit. Everything that I've been through tonight is a quick overview, and the general binding rules and permit application processes are all set out in much more detail on the .gov website. If you need to know any more about any of these, have a look at the general binding rules and contact the Environment Agency for more information. And then finally, follow the best practice guidelines to make sure that your system is operating as effectively as it can be. And I would summarize those guidelines by saying, be nice to your tank, don't overwhelm it, don't put anything too nasty into it, and make sure you empty it out once in a while. If people with private sewage systems do that, they will be making sure that they are contributing to a healthy water environment and not adding pressures to our already beleaguered water systems. Finally, a series of links to everything that I have mentioned this evening.